Today we are solving vowel spell checker. So in this we are given an array of word list and an array of query words. Okay, and we'll have to find if a word from a query has a match in the word list or not. But there are some catches. The very first catch is the capitalization. If if the query matches a word in the word list, we are talking about now in case insensitive. If there is a case like this, case insensitive case, then you can still have a complete match. Okay, if it's case insensitive. If it's exactly the case, then also it's again true, it's good. So we are fine by case sensitive and case insensitive both ways, so we can have a match on the basis of that. Coming up to the next section that they have provided, vowel errors. Okay, so what they are saying is replace the vowels and of the query word with any vowel individually. Okay, so I have an authority to given a query word, say YOLLOW, so they are allowing me to replace any vowel in this. So let's say I replace this O with an E. Okay, then it again makes a word from this word list. Case insensitive match will trigger, and this again is a match for me. Okay, so I get a match over here. Similarly, yeah, so this is the example where we need to be careful. Let's say we have double E. Now I in no way I can replace with another vowel to make it a single E, because I have two vowels over here, so that cannot be done. And this is yellow, and this is query is YLLW, so there is no space for substituting the vowels. So again, this is no match. So in both the cases, no match. Okay, now come to the crux part. This is the precedence rules, so you have to be very careful. First precedence rules talks about whether it's case sensitive. When you find an exact case matching, then you return it with the very first thing that you do. Return it. If you find something, you traverse the whole array or word list, and if something is matching via case, then you return it. If it is not matching, then the second rule states that you return the very first word that matches. If it's not case sensitive, then you go for via case insensitive route. So this is what the second one means. Coming to the third one, vowel error, like we talk about here. This is the vowel error one. So then we go to this vowel error. Now if there is no match, then you return an empty string. Okay, now coming to the example, one by one we will go over this word list and work it out. So KITE, kite, small, it's all small. Can we find something in the word list? Yes, this is the one kite that we are able to find in the word list. So what we will do, we will say, hey, this outputs over here, kite. Okay, so outputs are all coming from the word list itself. Whatever the outputs are, they are from word list. Okay, now capital KITE I don't have anywhere. So what I do is after doing a complete iteration, I didn't find anything, so I'll go where via case insensitive route, and this is this one, capital KITE. So I'll get this kite. So this one is that's why capital KITE we say over here. Okay, now coming to KITE, this is an exact case match. So directly in the very first section we get, so we do print it like this. Okay, now we say HARE, hare. Now we do a complete traversal and see where it is. Okay, we see it over here. Then what we do is we just print it over here, simply hare. Okay, now for this word HARE, all capital, do we have anything? No, we don't have anything all capital. Okay, then again, then we go by the case insensitive route, and then we stop over here because hare is a match via case insensitive route. So that's why we see over there hare. Okay, so this much we have completed. Okay, so let's cancel this out. Now here, for here I am having option of HEA and then R, so I can replace these two vowels. But if you see over here, you are having vowel in hare, this R and this location, so there is no way that here can be the part of string matching. There is impossible, that's impossible to match. So what we say that, hey, here cannot be the part, so we return empty. Again same here, again empty, so it cannot be the part. Then we come to KT. So for KT, let's find, we won't find any match in KT whether case sensitive by case insensitive. So what we do, K E T I. Okay, so I have this. So what can I write it like? I can write it like this. Okay, and kite was something like this, so I can write it like, right, like this. So you see, if you are having some same skeleton, so whatever vowel you put over here, you can, and whatever vowel you put over here, you can and make a match for this guy and this guy. So this way we say, okay, we will have a match. So what will we return? We return the very first one. So we return this up to over here. Okay, now for K double ET, same similar logic. You cannot have K, you cannot cover it like this. There is no way you can find any output like this. And keto you can find via kite. Okay, so this was the complete gist. Okay, just revising it again. Exact match, you have the very first rule, and then you have case insensitive match and match after vowel replace. Okay, so what, again revising on vowel replace, what you need to do is, if you have a word KITE, okay, so the best way to, you know, vowel replace is to, whatever the word you have in your word list, make a skeleton for this, K underscore T underscore. Okay, so any word can come over here. Okay, so that is great. Now I have something, let's say these words in my word list, sorry, in my query. Now again I do the same similar type of thing, K underscore T underscore. Now this and this are easy to match. Okay, in our program, so you can match it via this route. And similarly KATI, you underscore underscore, so this can match to this guy. And K double TI, this, there you can directly see there is no match in this case. You cannot compare this string and this string. There's no way that they are equal. Okay, now coming to the solution part. Okay, okay, so for the solution I wrote two helper function. First is a function that converts a given string into lower, basically, and then this remove vowel functionality. What I am doing is, over here I, whatever the string is there for me, let's say KT, then this output will be something like this. Okay, this is the output that we will get. Now coming to, from these two helper function, we want to have some precedence check, and we want to optimize a problem scenario. So what we do is, for O1 time lookup, we are using this unordered set. So what we are doing is, we are just populating it via word list, and for an exact scenario match, we will just refer to ordered set exact and find whether this word exists or not. And then we have another ordered map in this case, and then unordered set. So sorry, unordered map. So these two are unordered map, and this one is the set, my bad. Okay, so what these two are, this one will have case map, and this one will have vowel mapping. Vowel mapping will be the one that will be having this sort of mapping with and this will map with the word, with the very first word from the word list. And in the case map also, K, whatever the word is, let's say Kate, it will map whatever the first word occurrence of this is in the word list. So this is how we are doing a mapping. So building maps, same logic we are trying to do. We are building both the map, vowel map and the case map. So we firstly convert the word into lower, and then since we are beginning from, like, since we are loop is started from beginning only, so it will always be the first word, and as per the question we will always have to find the nearest and the first one. So first occurrence, then hence why I am putting this W over here, first word. what is this doing? You get the lower string and you check in the case map whether this low exists or not. If it doesn't exist, you create and you map it to the very first word. And similarly for remove vowel, you can have multiple occurrence. Let's say in your word list you have this, and then you have this, right? So you have multiple occurrences, you can have multiple occurrences. So what we do is remove vowel with low, and we get a mapping like this, right? And this will be the key, and the value will be the very first occurrence. So value will be the very first occurrence in our case. Now once we have built our data structures, what we need to do is resolve the queries. So first of all, pretty much a straightforward exact match. This is part which is doing the exact match, exact count, and if you get the exact match, then it's good. Else if we don't get an exact match, we move inside this. So we take the lower string and we take the removed vowel string from that query, and then we do a case wise comparison first of all, right? And if the case map again fails, then we go to the vowel wise comparison, and if vowel wise comparison also fails, we come to the empty string part, and then we return the answer. So that's it.